Hello class, today we're going to go ahead and look at our second day of factoring. We're going to look at ax squared plus bx plus c. And so today what's going to be different is we will have a number in front of our x squared. One thing that I want to take note of is that if I were to FOIL this in the past, like we did yesterday, I would have x, a binomial, and parentheses, and I would have another one. And let's say it would be plus some number, plus some number. Okay, if I wanted to check to see if these two things were the same, I would use FOIL. I would take my first two numbers, which would be x times x, okay, and I would get x squared. So the first two numbers being multiplied gives me this term. So this is from the f of FOIL. Okay. If I move on, I would take my outer two. So x times a number, which would give me x and some number. And then I would once again take my inner two, which would be x and some number. And then you would add those two together. Okay, so it will give you some number with x. So the way you get your middle term is by using your outer and your inner terms. Okay, and then in order to get the last term, okay, this is where I would take my last two numbers. So a number times a number will give me a number, and c we know is a number. So c comes from the last terms. So using that idea, we're going to start factoring binomials that have a coefficient greater than 1 in front of the x squared. So looking on our notes, okay, this should be a c here. Just to remind us, this the ax squared term came from the first terms. The bx terms came from the outer and the inner. And then my c term comes from the last. So keeping that in mind, we're going to go ahead and try and FOIL this. So I know it's going to break down into two sets of binomials. And I think of my factors of 2. Well, 2 is nice because it's a prime. And remember, a prime number is anything that it can only be divided by itself in 1. So I think 2, well, there's only one way to multiply to get to 2. It's going to be 2 and 1. And in order to get to x squared, okay, so I checked my first two terms. Do they multiply to my ax squared? That is correct. Now my last two, okay, so to get to 5, I have to say, well, the numbers in my last spot have to multiply to 5. Once again, 5 is prime. So I go ahead and I try 5 and 1. Okay, then I need to have my outer and my inner add to be 11. Okay, well, I would have 5 times x, which gives me 5x. And then I would have 2x times 1, which gives you 2x. Is there any way that I can have 5x and 2x get to 11x? I think to myself, well, no. So what I go ahead and do is I switch them around. Okay, I had 5 here, so now I'm going to put a 1 there. And I put 5 here. And once again, I check my outer and my inner. So this gives me x, and this gives me 2x times 5 gives you 10x. Can I add these two numbers together to get 11? Yes, I can. So they would both be positive. And here would be my binomial factored. Okay. Let's move on to example 2. Same idea. I'm going to have a binomial, so 2 binomials, and I think, well, what are my factors of 3? 3 again is prime, so I like this. So I know I'm going to have 3x and x. I check, do my first two multiply to give me my first term? Yes. Now I try my last term. Okay. The second number in my binomial has to multiply to 7, negative 7. So the nice thing here is that 7 is also prime. So I would have 7 and 1. I'm just going to give it a try. This would be 7x. This would be 3x. Okay, well, is there any way that I can have 7x and 3x get me to negative 4? Yes, there is. I would have negative 7x plus 3x gives me negative 4. So in order for that to happen, I would have to have negative 7 here and positive here. So there we go. Then I check my two first terms. Multiply together give me 3x squared. My last terms, negative 7 and 1, give me negative 7. And then my two inner, negative 7x plus 3x gives me negative 4x. So there it is, factored. Moving on to number 3. Okay, number 3, I look at number 3 and I see it's not quite as nice as the other ones because 4 is not a prime. Okay, so I might have to try a few times in order to get this one right. So my factors of 4, well, there's 1 times 4 and 2 times 2. I'm going to start with 2 times 2 because I know there's less options to check with that because I won't have to change them around. So I have 2x and 2x, and then the nice thing is 2 is prime, so I'm going to try 2 and 1. And so I check my 2 insides and my outside, so I get 4x and I get 2x. Is that going to get me to 9x? No, it is not. So then I know that it's not going to be 2x in the front. So I'm going to start over. My other options of 4 are 4x and 1x, so just x. Okay. Once again, my factors of 2 are 2 and 1. So I'm going to do 1 and 2 because I'm starting to see that my outside will be multiplied together. So this is going to give me 8x, and this will multiply together to give me x. So this gives me, when I add it, 9x. So they will both be positive, and everything checks out. So there is my solution. So it kind of starts to become like a little puzzle, and you want to put all the pieces together. So just trying to think logically through it. So like in 3, I seen I would have to, if I put a 1 here, I would have 4 times 1, and then I'd have 2 times 1, so that wouldn't get me anywhere. So that would not be enough. I'd have to switch it around. So starting to kind of think ahead, seeing what factors you have and what's going to be multiplied together. Let's go ahead and look at example 4. Okay, so I would have 2x squared. Well, the nice thing, like I said, is 2 is a prime, so I know I'm going to have 2 and 1. Those are my only options. But now 12. 12 has multiple factors. My factors of 12 are 1 times 12, 2 times 6, 3 times 4. So I have lots of combinations that I need to try, and I need to get to 5. Okay. I think if I put in 1 times 12, might be a little too much, too big of numbers. So I'm just going to try one of the smaller options. I'm going to start with 3 times 4. So I put in 3 and 4. So I check my 2 inner, I get 3x. My 2 outer, I get 8x. Can I get to 5 in any way? Yes, I can. I would have to have positive 5, so negative 3. So that's negative. This would be positive, and then I would check. Does negative 3 times 4 give you negative 12? Yes, it does. So there is my factored form. Okay. Moving on, example 5. Now, if you look here, 9 and 4, neither one are prime, so we might have a few options to try. I like to, if there's like the same number multiplied to get to it, I like to start with that one. So 3x and 3x. And I'm going to go ahead. My factors of 4, I'm going to try 2 and 2. Well, it's going to give me 6x, and this will give me 6x. Can I get to 15? No, I cannot. Maybe, there we go. And so now I'm going to try 4 and 1. This will give me 12x. This will give me 3x. Well, can I get to 15 with those numbers? Yes, I can. Both need to be positive because I want a positive 15 and I want a positive 4. So there is my solution for example 5. Okay. We are going to go ahead. I want you to have 6 and 7 and 8 all attempted by class tomorrow. And we're going to go ahead and look at number 9 together. So I'm expecting 6, 7, and 8 to be done when you get to class. Same method. The area of a rectangle. It says find the dimensions of the rectangle. Well, in order to find the dimensions, we have for area, remember it's length times width. So I need to know what my length and my width are. So what I'm going to do is I'm going to factor this trinomial. So I start out thinking, well, I have 8x squared plus 10x minus 3. So I'm going to make a binomial. I'm going to try 4 and 2, factors of 8, so 4x and 2x. And then 3 is nice because 3 is prime. So I'm going to try 3 and 1. So I check my two insides, gives me 6x, and the two outsides gives you 4x. Can I get to 10x that way? And I got lucky right away, and it will work. Both positive. Will this work? Well, if I want both positive, this will give you 10x, but will that give you a negative 3? It will not. So what I would do is I have to try a few more options, it looks like. So let's see here. What if I go ahead and switch it around? If I put 1 in the first binomial and 3 in the other binomial, this gives me 2x, this gives me 12x. Using that, could I get positive 10? Well, if I subtract 2, so I mean this would be negative, and this would be positive. Now when I multiply negative 1 times 3, do I get negative 3? Yes, I do. So here is my factored trinomial. And so what this tells me is area is length times width. So the dimensions of my length, or the rectangle's length, and width is 4x minus 1 and 2x plus 3. Okay. So go ahead. I want you to do 6, 7, 8 on your own. We will check the answers tomorrow, and I will see you then. Have a good night.